Okay, in the last video we worked on ionic compounds, or ionic bonds, form ionic compounds. Ions, remember, are atoms with a charge, gain or lose electrons. Now the second type of bond we're going to form is called a covalent. Okay, hopefully that kind of rings a bell. Valent, valence, outer electrons. Co just means together. So this is going to be a bond that forms between nonmetal atoms coming together, and they're going to share electrons. They share electrons to get a full octet. Just like ionic bonds, they want the full octet. One of the key things to remember is in nonmetals, they're only going to share out the number of electrons that they need to get the full octet. So if an atom has 7 valence electrons already, it only needs 1 to get its full octet. So it's only going to share out 1 electron. If it has a valence of 5, it needs 3 electrons, it's willing to share out 3 electrons to get a full octet. Keeping it very simple. Okay. So covalent bond. And paper stuck together. There we go. Okay, so let's go ahead and work a couple examples. And this is going to start off just like we had before on the ionics. We're going to start with Lewis dots. So Lewis dot for hydrogen, 1 dot. So we're going to bring that in. Lewis dot for chlorine, we're going to have 7. Group 17, we're 1 away from the full octet. Okay, great. Now, this is the way a covalent works, and this is the way I show it because to me it makes a little bit more sense. It's easy to visualize. Hydrogen, since it's in the very first ring, that very first ring can only hold 2 electrons, right? Well, hydrogen has 1 of the 2, so it needs to get 1 more. Chlorine has 7 valence electrons. It needs 1 more to get to 8, so it's only willing to share out 1 electron. How I show a covalent bond is I just circle the electrons that are going to be shared. So basically the way I look at it right now is this hydrogen has 2 electrons. This chlorine has 7, 8 electrons. They both have their equivalent of the full octets. That's how I show a covalent bond. Now, to write its formula, it's the same what we did on the ionics. We write the symbol of the elements. Don't put a gap between them. And then we just write how many we have of each one. And once again, if there's only one of them, you don't have to put a number, but for right now, I'm going to, just to help people kind of visualize that piece. Let's go to the next one. Hydrogen, keep with that. Valence of 1 still, not going to change. Oxygen has a valence of 6. It's 2 spots away from the full octet. Well, because it's 2 spots away from the full octet, that means it needs to have 2 electrons. Well, the hydrogen can only share 1 electron because that's all it's got. So I'm going to circle the ones that are being shared. And right there I can see that hydrogen has 2 valence electrons. First ring holds 2. This oxygen has 6, 7 electrons. It needs 1 more to get a full octet. And like we saw in the last video, where you have 1 atom of an element, you have billions. That means I've got another hydrogen atom floating around. And that hydrogen atom also has a valence of 1. And if we look, it needs 1 more electron to get a full octet. The oxygen needs 1 electron. So we're going to do that same thing there. We're going to share that between them. So if we look, that hydrogen, there's my 7 valence, or excuse me, there's my 2 valence for the hydrogen because there's only 2 electrons in the first ring. And if we look at the oxygen, it brought 6 electrons to the party and it's sharing, getting 2 more from the hydrogens. So there's its full octet. So if I'm going to summarize this, I know we said we always write metals first on the periodic table. Another way to think about it, always write the elements that's furthest left first in the formula. If you've got 2 that are in the same group, it's always the ones furthest left and furthest down. So in this case, hydrogen goes first, then oxygen. And if we look, hey, I've got 1, 2 hydrogens. So I do that. And there's our friend H2O. Let's go on to the next one. Carbon and oxygen. And carbon, I'm just going to do this. And I assume you, at this point, you can get the valence. If not, go back and start looking at the Lewis dots. And we've got this. Now, carbon, valence of 4, so it needs 4 more electrons. Oxygen has a valence of 6, so it needs 2 electrons. Well, it needs 2, it needs 4. That means this is willing to share out 2, this is willing to share out 4. I'm going to go through and say, okay, well, they're going to come through and they're going to share those electrons between them. So if we look at that, this oxygen now had 6, 7, 8 valence electrons. It's got its full octet. This carbon, 1, 2, 3, 4, that it originally had, 5 and 6, so it got 2 more from that oxygen. So now it's not its full octet, but it got closer. So what do? Well, where we have 1 atom of an element, we have billions. It needs 2 more electrons. It can't get them from itself, but it can from another oxygen. So in this case, I'm going to draw the oxygen over here. Doesn't matter where I put it, I just want to make it easier. And I'm going to do one thing. Instead of writing it this way, just to make things a little bit easier to visualize, I'm going to take this and I'm going to flip it over. So now I'm going to have the valence on the other side. I'm actually going to flip it vertically as well. So, but notice this is the same thing as this. I've just rotated it. And the reason I did that is so we can easily see this. He needs 2 electrons. She needs 2 electrons. If you want to give them genders, it doesn't matter. So they're going to share that between them. Okay. So if we look, this oxygen had 6, there's 7, there's 8. That carbon had 4, but when we do this, it's got 2 from this oxygen, it's got 2 from that oxygen. So now there are 8 electrons within those circles. So everything's got what it needs for the full octet. So summarize, if we look, carbon is further left than oxygen, so we're going to write that first. And say, okay, well, there's 1 carbon and 2 oxygens. So CO2. Remember, the 1 is optional. Go on to the next one. I've got nitrogen. Nitrogen, valence of 5. Okay. Or if you're just looking at your periodic table, since we're moving to that row, sorry. Nitrogen is right here. Well, there's 8, 7, 6, 5. 5 valence. And ultimately, we're just going to be able to look at that table and get them done. I know chlorine, valence of 7. Chlorine needs 1 electron. It will share out 1 electron. Nitrogen needs 3. It will share out 3. So if we look, just going to start doing this. Let me change, keep colors consistent at least. So we do that. That chlorine, 7, there's its 8th one. So it's good to go. This nitrogen had 5, there's its 6th. It needs 2 more electrons. Well, where did it get the initial one? From the chlorine. So it'll get more from a chlorine. So it's going to bring in another chlorine. Sorry, lost count. Okay, so with that, needs 1 more, needs 2 more. But if we do this, this chlorine has 7, there's its 8th. So it's got a full octet just like that chlorine. This nitrogen now has 1, 2, 3, 4, 5, 6, 7, because those are being shared. Closer to the full octet, not there yet. What do we need? Well, we need another electron. Where can we get it? Chlorine. So we're going to bring in another one. And just like we did with the oxygen above, I'm going to rotate this a little bit just so you can see it a little bit easier. You don't have to. This is just a way to think about them. And with that, I can easily see that, hey, these are going to be shared between them. That's the whole reason I did that. 1, 2, 3, 4, 5, 6, 7. There's my eighth one. So it's got its full octet. The nitrogen, 1, 2, 3, 4, 5, 6, 7, and 8. Now the nitrogen has its full octet. Okay, everything's got its full octet. Good to go. So let's go and summarize. So again, nitrogen further left than chlorine, so I'm going to write nitrogen first. And then chlorine. And go through and summarize. I've got 1 nitrogen, and then I've got 1, 2, 3 chlorine. So I've got NCl3. Hopefully you noticed on these, there's one thing I did not do that I did on the ionics. I didn't put down any charges. Why? Because in covalent compounds, there are no charges. They're sharing electrons. They're not giving them away. They're not taking them. They're sharing them between them. So the charge actually doesn't transfer. Covalent bonds, no charges. Okay, keep that in mind. Hopefully that makes sense. Otherwise, rewatch the video. Good to go.